Welcome to A-Level and AP Physics. In today's lesson, we will discuss two important questions on radioactivity, and these two questions are based on standard model and concept of isotopes. And these questions are from October-November 2020. For this question, four different nuclei P, Q, R, and S are given in this table with their number of neutrons and nucleon number. And question is asking us, we need to find out which two nuclei are isotopes of the same element. Now, first of all, let's try to understand what is atomic number, what is mass number, and what is nucleon number. First of all, let's try to understand what is atomic number. And the symbol for atomic number we use is Z. And atomic number is simply equal to number of protons. So we can simply write down it is equal to number of protons. And mass number simply equal to mass number. First of all, the symbol we use for mass number is capital A. And mass number is also equal to nucleon number. So we can also write down here it is equal to nucleon number. Mass number and nucleon number, they are equal to number of protons plus number of neutrons in the nucleus. Now, if we need to find out the number of neutrons or neutron number, symbol for neutron number we use is capital N, and this is simply equal to capital A means the mass number minus atomic number, so that will give us number of neutrons in the nucleus. Now, if we need to find out Z means the number of protons. Now from here, number of protons, if we need to find out, that simply will be equal to A minus capital N. Let's try to find out proton number, or simply the number of protons in the nucleus. So we can write down here proton number, and proton number is equal to atomic number, so we will use symbol Z for this one. As nucleon number is given, and nucleon number is the same as mass number, and the symbol for mass number is capital A, and the symbol for number of neutrons or neutron number is capital N. Now we need to find out proton number. So the proton number, as you can see here, is simply equal to, means the Z, this is equal to A minus N. A minus N. Now here we have A, so it means 10 minus 5. So the number of protons in P nucleus are equal to 5. Now for Q nucleus we can also find out. So this is 10 minus 6. So this is equal to 4. And for nucleus R we can also find out. That is 14 minus 6, so that will be equal to 8. For nucleus S, this is 16 minus 8, so this is also equal to 8. Let's try to understand isotope. Isotopes are atoms of the same element with same atomic number, means they have the same atomic number. We can simply write down same Z, but they have different mass number. So we can write down here they have different mass number, means different A. If they have the same atomic number, it also means that they have the same number of protons. So we can say they have same number of protons. So we can write down here, but they will have different number of neutrons. We can also write here different number of neutrons. This is what we need to understand. So isotopes, they have the same number of protons. Now if you look at these four nuclei, we can simply find out nucleus R and S. They have the same atomic number, they have the same number of protons, but they have different mass numbers. So the mass numbers are different. So it means they are isotope of the same element. So our answer is D. Question number 40 is about fundamental particle. Let's try to understand what is fundamental particle. Fundamental particle simply is a particle which cannot be divided into smaller parts, cannot be divided into smaller parts. Cannot be divided. So simply we can say which cannot be divided into smaller particles. We can write down also cannot be divided into smaller particles. So that particle we call is fundamental particle. Examples of fundamental particles are electrons. The best example and easy to understand example is electron. Electron is a fundamental particle. Muon is also fundamental particle. Tau is also fundamental particle. All of them, they are leptons. So electron we use symbol E, for muon we use symbol mu, and for tau we simply use symbol tau. Neutrinos are also fundamental particles. For example, we have electron neutrino, so this is fundamental particle. We have muon neutrino, this is also fundamental particle. We have tau neutrino, is also fundamental particle. Now let's try to answer this question. Alpha particle, this is not fundamental because alpha particle, it has two protons and it has two neutrons. I mean, it can be divided into smaller particles, but proton and neutron, they consist of quarks. For example, proton, it consists of two up quark, one down quark, and neutron, it consists of one up quark and two down quark. So this is not fundamental particle, but electron is fundamental particle, so this is our answer. Neutron is also not fundamental particle because it has one up quark and it has two down quarks, so it can be divided into smaller particles, so this is not answer. Proton is also not fundamental particle because it consists of two up quarks and one down quark, so this is also not fundamental because it can be divided into quarks. So our answer is B. That's the answer.